All right, I think we're live. This is live coding from Plutus PBL at Gimbal Labs. It's August 3rd, 2023. We meet on Wednesdays and Thursdays at 14:30 UTC. We will be taking the next few weeks off from official meetings. So after today, our next call is on the 23rd. Yeah, August 23rd. We'll get going again, 20 days from now. The goal for today is just to pick up where we left off yesterday, where we started going through the PPBL faucet project here at module 204 in the course. Here's the URL. And for anybody who needs the direct link, I'll just drop this in the chat. We did steps 1 through 3 yesterday, and we've got a couple of steps to go. Testing our unlocking transaction, registering with the aggregator, and then adding CBOR to the repo. So these are kind of a nice 3 steps because they take us kind of multi-layered through a process. First, we test things on our own. And is anybody on this step right now? I know Harsha completed step 3 live with us yesterday. Does anybody happen to be working on step 4 right now? All good. Okay, so I'm not going to demonstrate this, but just point to this bash script right here. All right, so provided in the Plutus template repo, there's a whole bunch of different bash scripts that are referenced throughout the course. And these are built, on the one hand, for you just to be able to use them. Okay, you should be able to pick this thing up and just get it to work. And that's what it says here, right? You'll need a contributor token. Okay, it's got to be in your CLI wallet. Okay, you got to prepare some datum. And this takes you through the process of creating some files that you'll need. And these by now should start to look similar when you make it to this point in the course. And it shows you how you have to customize your datum and redeemer. We add those paths to the script file. Those are going to be right here. Okay. And then you should be able to use this thing, right? If it works, it works. If it doesn't, it doesn't. What I really hope people are practicing, however, is even if you're provided with a script that does the job for you, the goal is to read through it and make sure you're understanding basically how it works. A lot of the times when we are testing contracts, you might want to separate the tasks of testing that your contract works in the first place versus implementing the off-chain code in a front-end project, okay? So this is the testing on-chain code first. We're going to build some transactions. We're going to make sure all the validators work. Once you get this transaction working, all right, now let's take that to a front end. Let's build a better UI than a bash script for the thing. So what do we have? Well, we're building a transaction, right? At the end of the day, we're going to have this built TX that we're going to sign and submit. And one by one, with a series of echo statements here. You see what it says? We're going to echo something, some string, into another file, right? And we call that file build-tx.sh. Okay. And at the end of this script, we show the file and we run it. And we build the transaction, then we sign and submit it. This is written this way so you can go through line by line and see what's being added to this transaction. Some of the lines are very simple, right? This is just our out file at the end of a transaction build, kind of like you see here or here. Or sorry, just like here, that's right. okay? But other lines here have variables in them. An address, right? It's got to be yours, right? The access asset, that's got to be your contributor token. The number of tokens you want to take from the faucet and the faucet asset. These are up to you to define. And all of these variables, you're going to enter those as you start to use the script. Okay, so yeah, we set up the datum and the redeemer files. Then we start to run the script and it says, okay, do a few things. Give us the path to your wallet directory. You copy and paste that into your terminal. It extracts your address and your S key from there. Give us the path to the Plutus script you compiled in step 2. Okay, provide that. Give us the path, give us the UTXO, the hash and the index of the reference UTXO you created earlier in the project. And then from there, okay, now we can query. We build the address for your particular contract. You just supplied the script right here. And then we say, okay, well, whatever that path is, let's create an address for that. And then let's build a transaction where we're going to grab a UTXO from that faucet address, right? And we're going to unlock it with some certain things here. Anyway, this should work. And the whole idea here is for you to see, like watching me use it is not the point. Okay, that's why I'm not demonstrating this today. It's up to you to try to get this thing running. And if you get stuck, you bring those questions to live code and we try to troubleshoot. And once you have it working, now you know you have a working instance of a PPBL faucet. So let me pause here. Any questions on anything from the high level view of how this thing works to the details of this bash script right here? What questions do you have? Okay. So once again, at the bottom, right, you can think about once you have a shell script working, and the reason this one is provided here is that it's for you to use as a blueprint, right? I think it's a really, really good idea to think about a bash script as documentation. And you can read through it from top to bottom, figure out how it works. Why is that valuable? Because once you know how it works, now it's just a matter of taking this whole process line by line and building transactions that do exactly the same thing in the front end, right? We need to grab a UTXO from the connected wallet. Good news. Mesh just takes care of that for us, so we don't have to worry about that part. We have to choose a UTXO from our wallet. Okay, well, actually, there's functions we can use in Mesh if we know what token we're looking for, and we can get exactly the UTXO we need with a given token in it and supply it to a transaction. And those are just two little examples, step by step, as you go through here. You look at what we're trying to achieve, you build a transaction to do it. Now it gets a little more complicated when we start talking about contracts. So with all of this in mind, I want to look at the source code for what we're going to see down here in the aggregator. Okay, we're going to circle back to these last two steps here after taking a look at the end result. The end result looks like this. Okay, you can see a bunch of these ugly purple squares just loaded up. Each one of these is separate. we're going to reiterate this point over and over again. This is a single website, PlutusPBL.io. And it's a single page on this website. Here's our faucet aggregator. But what are we looking at here? We are looking at a distributed application. Why? Because different contributors added different instances of a contract to this page. How'd they do it? Well, one, they did the steps that we've looked at already, right? They created their own faucet contract. They funded a treasury there by placing some tokens in it. And hopefully they tested it successfully, that using Cardano CLI, they could unlock from there. And now we've got a bunch of examples. Now you can see some of these examples actually look like they're broken. This one looks good. You can withdraw 200 airdrop tokens from a faucet that has 19,200 tokens in it and only one UTXO. This one, on the other hand, doesn't have any UTXOs at the contract address. See that? Faucet UTXOs is 0. Faucet balance isn't even showing up. Okay. And it says we can withdraw a lot of tokens. Not really clear if this is working correctly. And that's going to happen. This is guaranteed to happen. And this is part of what I want you to see with this project. When you build a decentralized application and you do start to aggregate different instances of contracts, guaranteed you're going to have some instances that might not be working right. So we need a way to troubleshoot that. We haven't done that yet. Okay. But at the end of the day, this is a new way of doing things, right? These are all coming from the Cardano blockchain, but they're all independent contract instances that were instantiated and are administered by different people, all of whom are working independently while placing an interface to their contract in the same place. So I want to look at this component right here. Right? I'd like to see, okay, how does this button work, right? Let's just test one of these once again. If I connect a wallet that has yep, that one has a contributor token in it. So if I connect this wallet, let's see, for example, if airdrop works. There's 19,200 tokens here now. If I press this withdraw button, I have an opportunity to confirm this. Okay. The signing page comes up. It says I'm going to get 200 airdrops. Yeah, that's the goal. The rest, the other 19,000 airdrops, are going to be sent back to the contract token. That's also the goal. Okay. Let's sign it and see if it works. I don't know if it's gonna. Success. Okay, it did. Excellent. We've got a transaction ID. We're gonna have some new UTXOs with that ID on them. And after this confirms on chain, I'll be able to reload this page and see that now there's 19,000 tokens left here. All right, so how did that work? What we're gonna do next is look at the source code for this component and just start to understand how we're building a transaction that does the exact same thing as this unlocking transaction in the bash script. We'll try to make connections between them. Give me 1 second here. I just have to make sure we got. Now I can go into the source code for the PPBL front-end template. We were just on the page for modules 204 faucet aggregator. And the way to find that is here in the components. And you all have access to this repo. Okay, this is up on GitLab. It's the one that a lot of people have already contributed to. And actually, in order to finish step 6 of this project, you have to submit a merge request to this repo. And we'll get to that by the end of this lesson. But here in module 204, okay, here's this faucet aggregator. Let's definitely open that up because we're going to want to look at it. This is you see, it's not a very long page, 22 lines of code. Most of it's just imports. What are we going to do? And actually, some of this stuff is not even being used right here. I can actually just get rid of those. Even better. Now let's get rid of this extra stuff here. That's nice. You can get rid of that and that. Cool. Now it's even fewer lines of code. Great. And let me run this locally just to make sure Adrian, hey, I was having so much fun. I got some updates for you with Andamio Plutus. Say that again. Hey, man. Let's go over here. So I'm going to run this thing locally so I can see changes if I make them. And so now if I just jump back to my browser for just a second, now I'm on my local host, but the same route, and you see everything is the same. Okay. Well, it didn't load yet. Hold on, let's load it. Oh, you know why? Should be good. Okay. So still working on the local host, then we can play around with it a little bit. You can see I just cleaned up that code a little bit, got rid of some unused imports. Fine. But what's the main thing we see here? Well, we see the title, obviously, right here. And then the only thing besides the title is our faucet list. All right, looks like that's where the action is going to happen. And we're passing a prop to the faucet list, a metadata key. More on that in just a second. And this is going to get us into looking at metadata and hopefully come full circle to talking about NFTs like Sebastian, you brought up yesterday. Let's look at this faucet list. Okay. This is also in the components. It's in course modules 204, but there's a subfolder here called components. Okay, so here's our faucet list component. How does that work? This actually, this also has some extra stuff in it. Let's clean up while we're here. Just extra imports. This is going to happen when you're in dev mode. You try a bunch of different things, and I didn't get around to cleaning up the extra stuff here yet, as we have been doing some ongoing refactors. All right, fine. Here we actually have a query. This is a GraphQL query. Use query is imported from Apollo client. You're introduced to this in module 201 just a little bit. You get your first chance to play with it. And here we're using a query to look at a certain metadata key. Which metadata key? Oh, the one we passed right here. It could be an arbitrary number. This is the golden ratio, which is without the decimal point, just for fun. Okay. And after we do that query, the page either is in a loading state, right? When we're still getting that data, we could show a little spinner. That looks nice. Okay. Or we can say that there's an error if an error happens. And sometimes when GraphQL is down, maybe you've seen that error message on the Plutus PBL site. And if we get data, we return a box, a grid, sorry, right? This grid only has one column in it, okay? If I changed this to a 2, let's see what that would do. Go back to the browser over here. If I have 2 template columns, what do you think is going to happen? Yeah, there it is. Okay, I can do 3. So right, once we start building components in React, it's easy to make these changes. It doesn't look very good. I don't want to side scroll for this. All right. So could argue that 2 looks okay. Maybe leave it that way. But just for now, I'm going to stick with 1. But this is the beauty of building these components. Which components? These ones. Okay, so what's in this grid? We start a grid, and then we take inside that grid the data from our query, and we map over it. We look at all of the transactions, and for each one, we're going to pass the metadata to this faucet dynamic instance component. Oh, what does that mean? Well, let's look at the query itself. All right, so metadata key query is defined also just in this project, but just in a different directory, data queries, metadata queries. So not components, but data queries, metadata queries. What does this look like? This is a basic query that allows us to look at any transaction with a certain metadata key. Let's see. Do I have GraphQL open? So here's the GraphQL playground. What I'm going to do is just straight from the front end. I'm just copying this from there. Oops. I need to copy a little bit more than that. Let's try this. That's better. Okay. And we have one variable. We have a metadata key. So down here, can everybody see enough? I can go a little bigger here. We know that we want a metadata key, and let's just use the one defined in our front end. All right, so if I run this query with this key, I'm going to get these results. Let's see what those say. Well, I get a bunch of transactions. How many? One, 2, 3, 4, 5, 6, 7, 8, 9, 10 transactions. Okay, so 10 people have submitted the transaction with this metadata key, and inside of that key, the following data. Here's Faizan's example. Right? Here's the policy ID of the faucet token. Here's the reference UTXO hash and index for the reference UTXO that was successfully deployed. The name of the token. Let's see. Faucet underscore token. There it is. Right? How many can I withdraw at once? 1. Just like you see right here. 1. Right? What about the one that I just used a few minutes ago? This one, you see, oh, there it is. Faucet balance is 19,000 now. And we can withdraw 200 tokens from airdrop. Let's find that metadata. Right. Airdrop, here it is. Okay. What's the withdrawal amount? In this case, it's 200. Yeah. That's that 200 right there. Okay, so this information is actually coming from an on-chain registry itself. And this is where we have to be a little clear. We're actually using the chain for 2 different things. One, we're using it to build validators with contract addresses where tokens get locked. But completely independent of that, we're creating an on-chain registry of working instances of this application. And that's what's in the metadata. Metadata is not like datum. We can't read it directly in our validator, okay? When I write validator code, I can look directly at the datum that's in a UTXO and I can use that in my logic. That's not true of this metadata. This is just like a dumb receipt that's on chain. However, even though I can't reference this directly in Plutus, I can use a tool like a front end to grab that information and use it as we start to build transactions. Let me pause here. I'm throwing a lot at you on purpose because we're starting to really get into some juicy stuff here. But what kind of questions does this raise for people? I'll keep going, but jump in if you're thinking about something. Now, part of what you need to know, right? Look, we're using this metadata key right here. And in history on pre-prod, as we just saw, this metadata key has only been used 10 times. If I changed this key to 721, I would get a different result. It might break my browser. I'm going to try it anyway. It's taken a while. Still going. It didn't take too long. Okay. This, and you know, if I ran that same query on mainnet, what would it return? Oh my gosh, it would return the metadata for every NFT that's ever been minted on Cardano. That would definitely break my browser. As you can see, right? Plenty. We could just keep scrolling down here, right? And this is what we would want to paginate. There's all sorts of stuff we want to do, right? But also, maybe I would not just search for a metadata key. You would never want to run this query on mainnet. It would just be an overwhelming amount of data. But we have other sorts of queries, okay? This is just an all-purpose grab all the data at this metadata key. But there's other things we can do. We can look for a metadata key and a wallet address. Or we could look for a policy ID, and we could look at minting transactions for that policy ID. And then we could look at the metadata for those. This would be a much better way to get NFT metadata, okay? And so, Sebastian, I know you're looking at just other providers that do some indexing for you and might provide a nice formatted result, but it's relatively straightforward if you want to try to figure this out, to use a query just like this one to get you all of the metadata for a given NFT. And we can circle back to this in just a moment and look at that after we go through the rest of this example. All right. In this case, we're just getting all 10 of those results from that query we're just looking at. And what happens to them? Well, each one of those transactions, right, map over the transactions. We're just going to call each one a TX. And what does each TX have in it? Oh, it has metadata. All right, let's look at that again. So remember this, data dot transactions, which is an array. And for each of those transactions, there's metadata, which is also an array. Check it out. Data, yep, That's the first thing we saw. What's the first field inside the data? Oh, transactions, data.transactions. There it is, right? And as you just saw, transactions is a list. There's our list. Anytime I have an array or a list, I can map over it. So that's what we do. We map over each of these 10 items. And so I would expect to see in my front end 10 of these purple boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There they are. The reason there's 10 here is because 10 faucet instances have been registered on chain at this metadata key. Now, what do each of those transactions have inside? Faizan, see you soon. One of the things they have is metadata. And that metadata has a value. Let's look. All right. This transaction has a few different fields. It's got a hash because we asked for a hash. It's got a timestamp because we asked for included at. And it's got metadata because we asked for that. Metadata is also a list because it's possible to include multiple bits of metadata in a given transaction. Right? I could say, okay, put this metadata over at key 721 and this metadata over at key 1618. And you could have as many different entries as you want, resulting in a list. And inside that list, what do we see? Well, here we just see one item, right? And every one of these items has a key and a value. Here they are. Key, that's the one we were searching for. And the value, that's actually the useful information. Value dot policy ID dot ref UTXO dot token name about, etc. Okay. So we take that value, and we pass that over to the faucet dynamic instance that we're actually printing. All right, so we got our grid, we got these instances, but what does the instance itself look like? Here it is. This is a much more interesting file. There's a lot going on here. Thank goodness you only have to write this once. Okay. What does it take as input? It takes that faucet metadata that we were just looking at. And what are the fields in that metadata? Contract address, policy ID, token name, withdrawal amount. Contract address, policy ID, token name somewhere, right? Withdrawal amount. Everything we can see that we're pulling into our front end is coming from on-chain. Justin's question, are there checks to prevent misformatted metadata from being displayed on the faucet page? Not yet. That's for us to do, and we might get to that in the next few minutes, okay? Because yeah, there is some bad metadata on here. But that's kind of exactly what we want you guys to have a chance to see. Hey, look, people are going to put wrong metadata up there. When that happens, what can I do about it? I can't change the blockchain. That's immutable. So what are my other options? Right. So all this data comes from there. And then we do a whole bunch of stuff to process it. Okay. Look, by the way, the about token part, which you can see right here, is not being used. Right. If I put my mouse over this, you can see it says about token is declared, but value is never read. Not even using that. I could, right? We could do a prettier design and maybe add that about stuff if we wanted to. That'd be pretty cool. But the key to what we're going to do here is we're going to build a transaction. And I'm not going to take the time to go through this entire file right here. But what I want to direct your attention to, we process a bunch of data. We make sure it's all good. This is very inefficient. but it's written out this way so you can kind of try to go through it line by line and start to see how all the different mesh functions work. Okay. I want you to see this bit right here. Handle faucet TX is the async function that fires. Let's find this. All right, this is, I define it here on line 293, and I use it down here. When we click the confirm button, handle faucet TX is going to fire. Just make sure we understand what's going on there. Where's the confirm button? I don't see a confirm button, right? I don't see it until I actually click the one I want to do. And then I get this little modal and there's the confirm button. Okay. So you'll see that we have this modal pop up. All right, this is just some Chakra UI. There's different ways you do modals depending on what design system you're using. Go ahead. This ugly little modal pops up when it's open. And that's actually what the first button does. Okay, so the button that says withdraw, this button right here, that says withdraw this many faucet tokens, right? What happens when you click that? Oh, we open up the confirmation. Okay, the confirmation opens up, and we could put more information in that. This confirmation sucks. Look at this. Those buttons are just mushed up against each other, and there's no information here to confirm. But that could be changed too. Okay, we could say, oh, you're about to withdraw this many of this token. Are you sure? Right. So that could be updated, and all of that would happen down here in the modal. Okay, and feel free to take this code and play with this. If that sounds like an interesting exercise to you to make a more beautiful modal right here, just clone this repo, play with it locally, and see if you can make the UI do something new that you like better. That's what it's here for. Okay, but we press that confirm button. The functionality is what I really want to share with you. Handle faucet TX once again. This uses mesh to build a new transaction. It's going to redeem some value from somewhere. Looks like the input faucet UTXO. It's going to send some value to somewhere. Looks like the contract address. It's going to send some assets back to what's address. In this case, address is the browser wallet. Okay. If I look up here, we're using a React hook called use address just to get the address of the connected wallet, just out of the box. Okay. Let's go back to that. And then we're also going to send some assets back to that address. We're going to send the connected contrib token unit. Okay, your contributor token. Where are we going to send it to? We're going to send it back to you. So actually, every time I make a withdrawal on a faucet, I'm actually going to get two output UTXOs, one with my contributor token, the other with the assets that I'm pulling from the faucet. Let's look at that on Cardano Scan for just a minute. So I have this connected NAMI wallet here, and with a recent transaction, 26 minutes ago, we looked at this together. Let's look at it on Cardano Scan. This this transaction had 4 output UTXOs, 3 of which went back to my wallet. One of them had my 200 airdrop tokens. Cool. with more than a min UTXO, 2 eta, right? You could make this a min UTXO if you wanted to, okay? I also got my contrib token with 2 eta in it. And then this is just the change. You're not going to see change every time, but often you will, right? So the rest of the change went back to me. The other UTXO was back to the contract address. Remember, before I unlocked those 200 tokens, there were 19,200 airdrop tokens there. What happened? 200 went to me, and the rest went back to the same contract address. Now you remember from yesterday, we're not allowed to change the datum. So if I look at this hash right here, D8799F18, should be the same as what I see here. And you see how it is? Or sorry, the hash is here. You can compare the hashes too. All right, so the datum hasn't changed. And you could inspect this. Here it is. I'm allowed to pull 200 tokens. The name of the token is this. And so we saw this in the Plutus yesterday. Here it is on chain. Okay, but here's our results. Now, why would we want to do that? Why go through the trouble of creating two different UTXOs out? Wouldn't it be nice to just include all of this in one UTXO? Yeah, sure, maybe on our end, but this is a nice thing to do to builders, or sorry, to users. Okay, you know that you're going to need your contrib token again, and it's a nice thing to have it by itself with just a min UTXO ready to go. That makes it easier moving forward. This is a decision you'll make as an app developer, deciding how to help your users manage their wallet in a nice way. Let me pause there once again. This is the high-level view of the transaction we're trying to build in our front end. What questions do you have about everything I just showed you there? Tiago, what's going on?
Oh, sorry, my mic is open.
It's
I
good to
did
hear
not
you,
saw
dude.
that.
Welcome.
Yeah, just taking some time to learn a bit more about the nuts and bolts. I need to start introducing or dev to more low-level execution of the contracts on Cardano. He's already well versed, but did not touch yet the smart contract. So I just drop in to understand what tools you guys are using, etc. Yeah,
Good things. Good to
languages.
hear. Yeah. How's this feel to everybody? Different people are on a different point in your learning about how building transactions work. But I've got a question, I guess. We were looking at that bash script earlier. And we start to build this transaction. We say, okay, I need my TX in, I need my collateral TX in, I need my TX in with my contributor token in it. I need the ones from the faucet. That's 4 different inputs. Where are all those inputs right here? Send value sounds like an output to me. Send assets, those sound like outputs too, don't they? This has the word input in it. And this is a really, really nice thing. If you've gone through kind of the labor of building transactions the hard way with Cardano CLI, when you start to use other libraries, and there's lots of them, right? There's a few different JavaScript libraries, Lucid, Mesh, for example. But then there's also, just depending on what languages you want to build, and there's all sorts of libraries for constructing transactions. And if you ever stumble upon one that you'd like to figure out more about, we can look at it together. But this is just one example. This is how Mesh does it. And Mesh says, hey, listen, if you want to send some assets to this address, and among those assets, you want to send a contributor token, don't worry about the input. We'll take care of that for you, right? We assume you're going to need the input with this token in it if you want to be able to send it. So over here, I had to specify that input. I had to find the TX in, right? With my access token, I had to specify TX in right here. But once I start using more abstracted libraries like this, that's no longer my concern. That's nice. Okay. I still have, oh, go ahead.
Yeah, the redeem function is the one that it's basically highlights when you need to put your transactions on the chain to make the UTXO move. So the redeem will be the main function to understand this process, right?
That's exactly right. Yeah, this right here is where our entire smart contract interaction is happening. That's exactly right. Okay. So yeah, sending some tokens from a wallet to a wallet, whether this could be to myself like it is right here, right? Or I could be, you could build a little app that lets you send money to your friends. That's a fun little project. Okay, just build a React project, make your own address book maybe, right? And make it easy just to send tokens around. That's a good way to start to learn a little bit. Okay, but this is the part where we really have a lot of work to do. Okay, and Mesh, it doesn't know the contract we're interacting with, so we have to tell it. Okay, so these are the parts right here where a little more work is going to go on. Input faucet UTXO. Let's find that. If I search for that in this file, you could see it happens 9 times. Let's start at the top. Okay. We make it a hook. Use state because we're going to build this thing as we go. This is not going to be necessary in the long term once you start to build your own libraries or use other people's libraries for kind of shortcuts for putting UTXOs together. More on that when we get to it a few months down the road, okay? But right here, we're going to use a use state hook so we can show you how to construct this thing. What is this thing? It's a UTXO. What's a UTXO? Actually, Mesh defines that for us, okay? So one of the things we're importing from Mesh is this UTXO type, which is nicely defined right here, and you can read about it in the documentation. But at first, it's not defined, right? So we initialize this hook undefined. Eventually, we want it to be a UTXO, and we can see, once again, this is how TypeScript works. As long as you're importing and defining types like this, you're always going to get guidance right here in your code editor, as long as it supports TypeScript, to see what you got to build. All right, so that's the thing we're gonna build. Where do we build it? Well, down here. Okay, so here you can see set input faucet UTXO. That's from the hook we just defined up here, right? Whenever this value changes, you use set input faucet UTXO. It's a function to change the value of that, to change the state of that variable. Okay. And what are we going to change it to? This is where we have to go through little by little and make sure we have exactly the information we need. Okay. This is one of the bits right here that's going to take up the most of your time when you're building smart contract interactions into a front end. All right, where exactly? How am I going to know the transaction hash and index of the UTXO I'm trying to spend. All right, you gotta be able to figure that out somehow. Where am I gonna, excuse me, what address is currently holding that UTXO? That might be trivial if you were already querying something like that. How much are we going to ascend? Or excuse me, how much are we unlocking? I'm getting my timelines messed up here, right? This is an existing UTXO and we're trying to construct it so that we can use it, right? And what's the data there? Well, you see this faucet query data, that is the result. Let's just search for it, it's easier. Faucet query data is the data returned by another GraphQL query. And this GraphQL query looks like this. All right. Look at an address for a certain asset and give us the UTXOs there. This is a high-level view. There's a lot of stuff that you're going to want to look at again if this is your first time seeing this. And if you've started to look at this stuff already, I hope it's helping to kind of see how these pieces fit together. Okay. But whoops. Let's just do this. Oh, it's there. Okay, good. Right. So we make the query. If we get data, we're going to call it this faucet query data. And then there's a bunch of different stuff there. Look, we can look at how many UTXOs, what's the length of the list of UTXOs. We hope it's one if it's a well-utilized faucet, but we already saw on our front end that there's at least one case where there's no UTXOs there. Right? Are there any cases where there's multiple ones? One. That one has 0. 1 is good. All right, so all of these are pretty well managed treasuries. Oh, this one doesn't have any. Okay, so we got 2 with 0. Yeah, we're certainly going to want to fix those somehow. But that's the idea. So this is an example of taking you full stack, right? Like you saw, there's a lot of code in this file. It's here so that you can start to understand it and hopefully start bridging for yourself the understanding from Cardano CLI approach, right? Everybody's on their own journey, understanding building transactions this way. When you feel confident about this, the best thing to do next is to take what you understand about building transactions this way and see if you can build the same transactions over here. It's not just about building the UTXO. We need a reference UTXO. This is a little bit of an advanced topic. It's taken care of for you, and we'll get to this. I hope that as people start to mess around with their own contracts, if you have questions about the reference UTXO, just bring those questions. And same thing with redeemers and datum, okay? This is getting easier, but the most of my time that I've spent kind of banging my head against this has been spent on making sure I'm constructing redeemers and datum the right way. Let's look for redeemer for just a sec. It's also a hook. And in this case, it looks like this. And you can compare this to the redeemer you see in the course, right? Where we show you how to build a JSON file. The way Mesh handles redeemers is a little bit different. And same thing with datum. Okay. We are gonna, I want this outgoing datum. Where'd that come from, right? Outgoing datum just has to be the same. Remember, we can't change it. That's in the Plutus contract. We saw that yesterday. So the withdrawal amount and the faucet token name is all we need. So that one's actually pretty easy to create. But sometimes, especially when you're dealing with dynamic data or a bunch of different UTXOs, each of which has different data. You're going to have to be ready to process that data into exactly the shape it needs to be. Questions at this point? Wait, so remember that the PBL front-end template that's available for anybody to look at. It's right here. Drop this link into chat just in case anybody needs it. And you can jump in, you can clone this thing. You can navigate to the same directory I was just in, course modules 204, components. Okay, here's the faucet list. We looked at that. We looked at the dynamic instance. There's also just a test instance here with hard-coded values. And if you want to play with it this way, you can do that too. So this is the one at the bottom of the page, the T scaffold down here. Okay, there's just a ready to go template if you don't need to make a dynamic instance. But I really hope people will jump into this code, take a look at it. Now, you might already be aware of this template. You've had a few opportunities to contribute to it. And if I look, for example, if I look at merge requests, we can see that different students in the course have made their own commitments. Okay, got our translation team. Thank you, Seb. Okay, and different people adding tokens. So what are people adding? Well, that's this bit right here. Okay. So we looked for a minute at registering with the aggregator. We looked at the resulting metadata for that. That's step 5. And once your faucet works, you're going to build a transaction with appropriate metadata. And this guides you through it. Now you know how to know if you did it right, right? If you do this right, you're going to be able to see your results in the aggregator. It happens automatically, right? Nobody can stop this. Right. Well, we can blacklist, and that's what we'll talk about to answer Justin's question in just a second. Okay. But the moment you add metadata like this to a transaction on the pre-prod chain, you just saw this page is going to be populated by your data. That's how it works. Okay. Nobody has to do anything else to the front end project if the chain is updated. That's step 5. There's instructions here, and there's a script to do this for you. This script is a little bit simpler than the one we were looking at before. You just have to specify the metadata path and where you're sending it, okay? And then we build a relatively simple transaction, right? It's just, all you're doing is you're sending a TX in to yourself. There's no TX outs here, right? You're just sending a transaction to yourself with some metadata on it. That's all. Okay, that's the registration step. I think there's lots of cool stuff for us to do with on-chain registries of aggregated applications. And that's why we wanted to share this project with you, is because this is a pattern that's going to become very popular in the years to come, right? Many people running their own contract instance, single front ends where those instances are aggregated. That's step 5. With the script provided. Now, finally, and here's that query once again, you can look to see if yours, right, in the GraphQL playground, you can look to see that yours worked. But there's this one more step. This is not 100% necessary anymore. there's actually tools that are live now that allow us to share reference scripts and to actually find the CBOR by querying the chain directly. But GraphQL doesn't provide it yet. So this gives us a nice little challenge. And that's that, it's if we want to use GraphQL to pull a reference UTXO, the CBOR is not going to be part of that yet. I think it probably will be in the future. I know that Go Maestro has published some tools already where if you know the hash of a Plutus script that you want to use, you can search the chain for that hash and you can find it. And that's going to make this step that's on my screen right now unnecessary. But just to take us full circle, to look at the state of things for right now, and by the way, to make sure that you've mastered making contributions on Git, the last step we have you doing is adding your contract CBOR to that file we were just looking at. Okay, so we saw like Faizan's commitment right here added to this file, faucet mini project / faucets-plutus.json. And that's what it says to do right here. Okay. Look at how the data is structured. This is the file in question. And your job is to add a key and a value pair because we need to have that Plutus CBOR string because GraphQL doesn't provide it. And so this is the approach we're taking for now. So the metadata will ensure that your instance shows up in the aggregator, but people won't be able to use it until you've added the specific CBOR that's yours. Let me pause once again for questions. How's everybody feeling? This went on like a 80-minute monologue. Do you see any patterns here that might be useful to something you're thinking of building?
Can you ask again, James?
Yeah, so what you've seen from this example, can you see this being applicable to anything that you want to build?
One of the common questions of the students is how to establish the interactions between the smart contracts and the front end, how to make the trick between both parts. I think the students in general don't have an idea in mind, but when they understand how to connect both parts, the magic starts.
I agree. I can't wait. People are still building out mental models for how these pieces work, but we're about to see an explosion of innovation as people wrap their minds around this.
Absolutely, because for the moment, people are starting to understand how to connect both parts. Until this point, we have some kind of profundization in the backend part, in the smart contract part. But people is starting to understand that you have to interact with the real world. So this is a really interesting part in this moment of the ecosystem.
James, do you have something on the lines of CP68?
100%. So you see that we are in module 204 right now. Okay, so this is the halfway point of the course.
Okay.
Okay, and so we have 8 modules published so far. And guess what? In module 100, when you start the course, you will mint a token that's following a bit of the CIP68 standard from right here in your browser. Okay, so we have
why the tokens follow a bit?
I'm glad you caught that. No, I did that on purpose. Okay. Why is it a bit? Let's look at CIP68 for just a second to answer that question. Okay, so CIP68 it's an NFT datum standard. Okay. And so specifically, this CIP is looking at traditional Cardano NFT structures of data, image link, properties, that kind of stuff, right?
Okay.
And the goal is to be able to use this standard to show people, an NFT, a picture of an NFT on a web page or in a wallet or something. Okay.
Mm-hmm.
We're not concerned with that part. What we are concerned with is the pattern of having a 222 token, some token that's in somebody's wallet, and a 100 token, some token that's at some other address. All right. The NFT data part, anybody who wants that can do that. Okay. Like that's, if you can follow this pattern and you can do it. What I think is much more interesting is just the general case of now, okay, when you mint this thing, and let me see, I think I already have one. So yeah, it tells me I have one. Let me switch wallets. I need a wallet that doesn't have one yet. All right, this one doesn't have one, right? So right here, very first lesson in the course, you get to mint your token. You can give it a name. Let's see, like if I tried to do James, it wouldn't let me because that one's taken already. Okay, but yeah, that one would work. When I press this mint button, I'm not going to sign this transaction. I don't want this thing. It's actually minting 2 tokens. One of them, you see how it says 222 at the front. I'm going to get that one. The other one is sent to a contract address, and it has the same name, but just with the number 100 on the front instead of 222. And so that's the first thing you do in this course is you mint a CIP68 token. And then as you start to move through the course, you learn the implications of that. You learn how to use it. You'll get to change the datum on your token, and you'll see the results of it. So if I look at the list of everybody who has minted one of these tokens, you can see 155 people have done that step so far. Okay. Mm-hmm. You're going to have some datum. And what CIP68 tokens allow us to do is they allow you, the student, anybody, to have a token in your wallet, and it doesn't matter where that token is. The datum associated with that token can change over time according to different rules. So when you first mint your token, you have a lucky number assigned to you. The lucky number is 5 because that's how long an epoch is, okay? But you learn by going through the lessons how to change your lucky number to a different value. And everybody who doesn't have a lucky number of 5 has accomplished that. And you can see this is just on-chain data right here. 26 people have done that step so far. Most people haven't gotten even that far yet. But yeah, invite you to start learning how that works. And then these accomplishments here, this is also on chain and it's attached to your contributor token.
When you're passing the minting transactions, where are you setting the 5 number?
I'll show you.
and
That's
how
the-
you are passing.
So that's back in
Basically,
module. Yep.
basically, this is like it's fixed on the spot. It's not a contract execution.
So here's the lesson we were just looking at, right? That has the minter in it is down here. So you can see there's a contributor pair minting component that's defined right here. So this is the file you would want to look at. And this is, again, that's in the same public repo we were just looking at. So a few things happen, but yeah, this is where the number 5 is set. So when you initially mint your token, you have a lucky number of 5, and you have an empty list of accomplishments. Over time, the list fills up and you learn how to change your number. This is trivial data, right? Lucky number is probably not going to be important in the long term, but we just want people to start to understand how this works. Now, you said, is it a contract minting? Actually, it is. So if I go down to the transaction build, here it is, right? We're minting an asset. We're minting 2 of them. There's the one that goes in your wallet, and there's the one that goes to the contract address. But it is actually a Plutus minting script that's being employed. Okay. Additionally, the one that doesn't go to you, which is called the reference asset, that actually gets locked at a contract address, and that contract dictates who can change what parts of this datum. All right, we have a recording from yesterday's live coding session where we looked at that Plutus code. You can take a look at it and you can review that code too and come back with questions, okay? But basically the way the contract works is only the owner of the contributor token can change the lucky number, but only a teacher in the course can change your accomplishments, the modules you've completed.
Cool.
Okay, so we just put a lot on the table here. The reason for this, we're going to take 2 weeks off from live coding the next 2 weeks officially. Everybody's welcome to coordinate in the Gimbal Lab server if you're around and you want to do some study time together. This live session on Wednesdays and Thursdays will be back up and running again on August 23rd, the Wednesday, and we'll continue through the fall. We might miss a few for like the Cardano Summit or something, but for the most part, we'll be doing this for the next few months, starting on August 23rd. Lots to look at. Any other questions before we break?
I'm cool. I need to check the other contract to be able to ask more questions anyway.
Of course. Yeah, no, take your time, be in touch. We'll this is probably a lecture that will need to be repeated, you know, a couple of weeks or a month or two from now. Because we're continuing to give people chances to access this stuff and to ask new questions.
Yeah, I like a lot to see the implementation going in TypeScript. It helps a lot to abstract, but I think when we go back to the contract, there's no way we need to do it in Plutus, right?
Oh, I mean, types must be defined in Plutus. That's part of the beauty of it. Yes, there's actually a really nice through line from Haskell Plutus to TypeScript.
Also, you're doing the contract in TypeScript too?
No, these contracts were written in Plutus TX.
Okay. By the way, any ideas around Aiken or?
Yeah, so in the course, you'll be introduced to the very basics of Aiken, but Aiken has been developed a lot since this course went live. And coming up, we will publish an Aiken module that teaches people how to build the same faucet contract we were just looking at. So now that you know it in Plutus TX, the idea is here's an alternative implementation, right? We want people to wrap their mind around one thing and then to be able to compare on their own. Okay, here's how I would do it in Aiken. What do I like better, Plutus TX or Aiken, or maybe Option or PluTS or Helios, right? So we take that basic contract, look at it a bunch of different ways.
Cool.
All right. So until next time, thanks for hanging, everybody. And anybody who's catching up with this video later, don't be shy. I expect that people will have questions the first time they go through this stuff, and can't wait to hear what people have when we get going in a couple of weeks.
Where are the other videos, James?
So here, take a look at the website. It's plutuspbl.io. This is actually, I think I'm running it locally right now. Yeah, let's go to, all you need to know is plutuspbl.io. All sorts of links for jumping in and getting started, but there's a live coding link at the top of the page where there's an archive of all of our recording meetings since March. You can review all of those here. When we go off air, Adrian, can we stick around for just a few minutes, and can I ask you a question about Andamio Plutus?
Yes, sure.
Cool. All right. Well, if you're watching this, see you soon. And we'll stick around off